Today we're going to talk about polar graphing. So you'll notice I put all of these r theta charts everywhere. I recommend you do that too. It will make it easier for you. So what's interesting about this is it's r comma theta, but I'm going to put a big star for you here. In our minds, it will be easier to start with theta when possible. That's because it's easier to think about the angle first. So just like last class, when we were graphing these coordinates, think about theta and then do r. Okay, now for this first question, obviously r is 3, so there's really not much to think about for r. I'm just going to write 3 here. We'll do 3 points. And that means theta could be anything. So theta could be 0, theta could be pi over 2. You could pick anything. Now the way we're going to do this is I'm just going to label them like this, 1, 2, 3, and I'll put my points down. So 3, 0 would be right here. And then 3 pi would be right here. And 3 pi over 2 would be right here. I'm going to label them 0.1, 0.2, 0.3. And I will ask that you do the same thing. And now all we're going to do is draw a circle. Right there. And there it is. There's our first polar graph. It's a nice circle. Let's go to our next one. This one says theta is pi over 4, so that's interesting. So again, I'm going to do 3 points. And pi over 4 is the fixed angle. And that means r could be anything. So r could be 1, r could be 2. You could even pick a negative number like -3. So let's put 1 pi over 4. So that's in pi over 4, that's 1. And then 2. And -3, remember negative means go backwards. So 1, 2, 3 in the opposite direction. I'm going to label this for you right now. So 1, 2, 3. And look at that. It's just a straight line. And that makes sense because they're all going to land on that pi over 4 line. And don't forget your arrows. The arrows indicate they go on forever, so you don't want to forget to include that. So our next example is r sine theta equals 2. Now for this one, we want to pick good angles that work with the sine function. So for example, I'm going to write r sine blank equals 2 and just work it out. So by good angle, I mean something like pi over 6. That's because sine of pi over 6 is 1/2. So solve that for r. R is 4. So what's another good angle for sine? 5 pi over 6. Because that would also make a half. So r must be 4. So now let's think of another good angle. Pi over 2. Because what's sine pi over 2? That's 1. So if I have pi over 2, let's solve for r. R must be 2. Let's graph those points. 4, 5 pi over 6, 4, 5 pi over 6, and 2 pi over 2. Let's label them 1, 2, 3, 1, 2, 3, and let's connect them. And you'll notice that they make a horizontal line. Pretty interesting. Now the reason for that is because recall yesterday we have a polar fact that r sine theta is equal to y. So highlight this right here, r sine theta. That would mean y must equal 2, which is exactly the line we see there. Y equals 2. And if you can't see it, you can kind of superimpose the x and y axis right here. So imagine the y-axis is there, the x-axis is right there. Now it's easy to see that that is the line y equals 2. Next example, you can probably guess what's going to happen here. R cosine theta equals -3. So of course you could just draw the vertical line because you can probably already see that this is x equals -3 since the polar fact is r cosine theta equals x. But we want to practice our polar graphing. So let's not do that. We just know that's what's going to happen. R cosine blank equals -3. So for sine, we like pi over 6. For cosine, we like pi over 3. That's because cosine pi over 3 is 1/2. So if theta is pi over 3, r is going to be -6. Okay, let's try another one. Another good angle for cosine, I'm going to use pi, since cosine pi is -1. And look at that, I can solve. R must be 3. And let's do another good angle. So again, anything that makes positive or negative half is good. So I'm going to use 2 pi over 3 here. So cosine 2 pi over 3, that's going to be -1/2. So if it's 2 pi over 3, that would be +6. Let's graph it. So -6 pi over 3, that would be right here. 3 pi would be right here. And 6 2 pi over 3, that's right there. Let's label those 1, 2, 3. So that would be right here, 1, 2, and 3. Let's put the line in. And there it is. Now a lot of people ask, how do you know what coordinates to pick? And again, we're trying to pick things that make nice numbers, like half or 1. But you'll notice that I did not pick 5 pi over 3. So I'll put this in green. 5 pi over 3. Now you're going to see why I didn't do that right here. If I had picked 5 pi over 3, I'll try that. 5 pi over 3. Cosine of 5 pi over 3 is +1/2. So if I use 5 pi over 3, r would have been -6. But look at the problem. If I had used 5 pi over 3, that's right here, go -6, we actually end up going over here, this point. Which means, look at that, these 2 points, they're the same. So if I were to pick 5 pi over 3, I mean, I could have done that instead of 2 pi over 3, but you wouldn't want to pick these 2 points together. And that's because they overlap. And the reason they overlap is because in problems like this, they're 180 apart. That's pretty interesting here. So for lines, you kind of want to avoid picking points that are 180 apart. But if you did it, it's not a big deal because you could just pick another point. But that's kind of why you see like I avoided 5 pi over 3. But I guess I could have done that earlier instead of 2 pi over 3. But I'm just showing you that it can happen where you pick overlapping points. Okay, next one. So at this point, you're probably seeing I give hints right here. This is going to be a circle. Now to do this, we're going to pick some points again. So for sine, hopefully we're remembering some easy points. So I want sine pi over 6. That would be 1/2. So 1/2 of 4 is 2. Let's plug in 5 pi over 6. That would again be 2. And then let's plug in pi over 2. That'd be 1. That's going to be 4. And the last one I'm going to pick is I'm actually going to use pi. Now that's pretty cool because sine of pi is 0, which means we actually get pi comma 0. That's a pretty cool point. So let's graph that. 2 pi over 6, that would be right here. And then 5 pi over 6, 2, that's right there. 4 pi over 2, that's right here. And then 0 pi is the origin point, that's right there. Now to make it easier, I'm going to draw in the axis. Here's the x-axis, here's the y-axis. It'll make it a little bit easier to see the circle. Because now, when I try to draw this, there it is. There's our nice circle. 1, 2, 3, 4. So again, here's our first point. Here's our second point. Here's our third point, and right there is our fourth point. So pretty cool. There's our circle, and notice how it's sitting right on top of the x-axis. So there's our first one. Now let's do the second one, and let's see what happens. -2 cosine theta. So I'm going to write r equals -2 cosine of blank. Let's pick a good angle. I'll start with pi over 3. So -2 cosine pi over 3 is 1/2. So pi over 3 is going to make -1. Let's plug in 5 pi over 3. And then we're going to get, that'll also be a 1/2, so that would be -1. Let's plug in pi. That'd be -1. So pi would be 2. And then I'm going to plug in pi over 2. So quadrantals are pretty helpful here just because they give you like nice points like the origin point, because that would be 0. So pi over 2 is 0. And again, for reference, I'm going to draw in the y-axis and the x-axis here. For circles, I do find it very helpful to do this, because now when I put the point pi over 3 -1, that's right here. 5 pi over 3 -1, that's right here. 2 pi, 0 pi over 2. Now there's our circle right there. 1, 2, 3, 4. So there's our 1, there's our 2, 3, 4. There's our 4 points. Now what's interesting about this is really notice where the circles are. For the sine circles, look how that positive one is sitting on top of the axis. So this is a positive sine circle. Positive sine circle, which would mean the negative sine circle would be sitting right below. Negative sine circle. Notice also that this 4 right here actually related to the circle. Look at this leg right here. That's 4. Same thing. Which means that is the diameter. So for cosine, we can see that here. Look at this 2. The diameter here is 2. That's going right there. And for cosine circles, if you imagine the axis, look at how this one is sitting on the left, right here. That's going to be a negative cosine circle. If it were positive, it would be on the right. Okay, so that's our intro to polar graphing.